Hi everyone, this is the second video of putting it all together for VBA. In the previous one we didn't get the chance to practice conditionals or if statements. So the purpose of this one is to follow the example we did in class, if you need to practice or if you couldn't make it to class, and use each of the tools we've learned to practice conditionals. So once again, like I said in the last video, if you haven't already, you need to have gone through each of the videos from VBA Day 1 right here and VBA 2 before you watch this video, or you need to have come to class. You don't have to watch the videos if you've already seen it all and done the reading. So this is our chance to practice. Back here, let's work on this problem. So here's our flow chart. The idea is we've got a donut store and we need to input NOD, the number of donuts someone wants. Okay, then if they're ordering more than a dozen or more donuts, let's change that. If they're ordering fewer than a dozen donuts, we're going to charge them 60 cents a donut. If they're ordering a dozen or more, it'll be only 40 cents. Then we're going to print out the number they said they wanted and the bill. Actually, let's put that out in a message box. But let's begin by creating an input over here for them to tell us how many donuts they want. NOD, number of donuts. Okay, put a nice pretty little border around it, right line it. Okay, that's where we're going to collect our input. Okay, so hopefully if you watched the first video, you're getting a little bit better at this. So how do we begin? Alt F11, let's open up our VBA module. I'm going to close out all this other code that's in here. And I want to put this code into a new module. By the way, this is the file we used in class, and you'll notice that there's code here, solutions to everything that's in this file. Actually, I don't see our number of donuts code. Perfect, because we're going to write that together. All right, I'm going to close that out. Let's insert a new module. Let's add option explicit at the top, like we always should. Okay, let's create our sub. I want to call this Donut Shop. Okay, once again, we've got 3 steps. I'm going to put those in. Step 1, we need to collect inputs. Step 2, perform the processing. Step 3, output the results. Right? So again, these are comments. Because they're green, they're not ever going to be processed. It's there for our own good to help us remember how to get started. Okay, inputs. Let's take a look at our flowchart. It looks like all we need is the number of donuts. Not so bad. Dim. I typically don't like using these uppercase variable names, even though they're in the example. So I'm going to switch to lowercase. Number of donuts as, what type of data type uses only whole numbers? Integer. Okay. So we've created the variable, the name storage location for NOD. Next step, we need to assign it a value. So NOD is going to equal what exactly? Okay, sometimes we've used input boxes, sometimes we use something called range. The idea is we're trying to get the data from the user. So in this case, we made a cell over here where we're going to enter the number of donuts in. So we need to take the value from here and store it in this variable NOD. Again, we call this an assignment statement. Whatever's on the left-hand side of the equal sign is going to be changed to the value of whatever's on the right-hand side of the equal sign. In this case, it's range. Where to put that again? B2. So again, B2 is the address of the cell right here. Oops, B2. Let's talk for a second about objects, methods, and properties again. So we've had this in class. There's 3, everything in programming is an object. And objects have methods and properties. A dog is an object. So that's our analogy. A dog has properties like name, age. We can read the properties and we can set them to something if we want to. We can set the dog's name and we can get the dog's name. We can store the dog's name into a variable or we can set it. So properties are things that can be set and get. For example, range B2 is an object. A workbook is an object. A cell is an object. There are objects that are within objects. So range B2 is an object and it has properties and methods, just like a dog has properties. If we hit the dot after range, we get a list of properties and methods. One property is what's the address of this cell. The one that we're using, borders is a property. Okay, the thickness of the border, the color, the style. So value, what's inside of the cell, that's a property as well. Now you've also learned things like .select. Okay, any of these options here with this little hand holding a piece of paper is a property. Any of them with this weird little moving eraser, I don't know what that is. That's a method. So you've learned probably the select methods, which means move the cursor to this cell. You're doing something. So a dog has methods like bark, sleep, stuff like that. It's not something you're setting or getting, it's something you're making the object do. So in Excel here, a .select is a method because you're making the cursor move to a spot. So you don't use a method in an assignment statement with an equal sign. Well, there are times where you would, but typically what we're talking about with an equal sign is we're trying to read a property and store it into a variable. So that's what we're doing here. We're saying range B2 is an object, .value is the property we want stored inside this NOD variable right here. Okay, so we've collected our input. Next step, processing. Okay, bill should be something as simple as bill. Well, before we can create the bill, we need to create a variable for it. Bill as currency. Okay, bill is going to be equal number of donuts times what? Either 0.6 or 0.4. We don't know which one yet. So I'm going to make both of them for now. Bill equals number of donuts times 0.4. Bill equals number of donuts times 0.6. Okay, the problem is we don't want both of these lines to be processed. We only want one of them to be processed. This one or that one, depending on the value they give us for number of donuts. Is it greater than or less than 12? So to help us select and control the flow of this function, we use what we call a control structure. And there's several types of control structures. One of them is a conditional, an if statement. That's one type of control structure that lets us control where the processing happens in a function. So I'm going to move down here, give it some space, and create our if statement, our conditional control structure. So if statements begin with the keyword if, and then you have a condition that needs to be evaluated. So this is the same as what we did in Access in the database section. So we want to run a query where this equals that, or this is greater than that, or this is less than that. So each of those conditions can be evaluated, it has to be able to be evaluated as a true-false value. So our evaluation is if number of donuts is less than 12, there's our condition, and before the condition is the keyword if, after the condition is the keyword then, and before I forget I'm going to put an end if here. So if this condition is evaluated as being true, then whatever is in between this if and end if, whatever we put in here is going to get processed. So if it's less than 12, then we want to charge them the higher price. Bill equals number of donuts times 6. Tab that in. If it's not, then we want them to charge them 40 cents. So we actually could leave it just like this. No, actually, excuse me, we couldn't. If we put this up here, home, then what would happen is initially everyone's bill would be sent to 40 cents a donut. That would be processed, and then down here, if the number of donuts was less than 12, it would then overwrite it. So this statement right here would overwrite that one because it comes second if this condition's met. If the condition's not met, no problem. It stays at 40 cents as specified right up here. Let me show you what I mean. Let's go into debug mode and let's step into. So F8 enters us into debug mode in a PC, Command-Shift-I on a Mac. So F8, open up our locals window. Alright, number of donuts and bill. Let's go back here and let's plug in a value, 8. So if they order 8 donuts, should be 60 cents a donut, right? Actually, let's just put in 1 to make it simple. Okay, F8 again. It says number of donuts. It's going to grab from that cell. We hit F8. It processes that line. Notice now number of donuts is now set to the number 1. F8 again. Now bill is set to 40 cents. Okay, is that correct? Should it be 40 cents? No, but that's why we've got this conditional here. If number of donuts is less than 12, which it is, so we hit F8, and now goes inside the if statement to this line. Now, this will overwrite the value of bill to number of donuts times 60 cents. Hit F8, there we go. Now the bill is changed to 60 cents. Hit F8 again and we're done. So this works. Let's go back and put in 12 donuts. Okay, now let's stop and restart this. F8. Range grabs a value, 12. That's correct. Hit F8 again. Now it says, is it less than 12? No, it's not. So if we hit F8 again, notice it skips over this line entirely and goes straight to the end if, leaving the value at 40 cents a donut as it should be. So this works. It gets us the right value. And in fact, if you did it this way on an exam, you'd be perfectly fine. However, it is a bit of a waste. Well, actually, before I get to that point, let's finish and print out the output. So I'm going to use a message box to say inside the double quotes, your bill is, never mind, I've changed my mind because the message box tends to convert all currency in types into string data types. It confuses people. So let's stick with range. Let's go back here and let's print it out right here. Total. Let's give it a nice thick border. Let's write a line. This. Okay. So let's print it out here in cell B4. So we reverse the assignment statement to output. Range B4 value is going to equal bill. Alright, so let's finish running this now. I'm going to hit F8 again, and now it prints it out and sub. There it is, 480. So let's go back and improve this function a bit. We shouldn't have to calculate the bill twice if it's only ever going to be the value inside of here. So we can expand an if statement into an if else. So we simply go down a line and add an else. Notice it turns blue, it's also a keyword. And we're going to take this value and move it down here into this else area. Whoops. Okay. Now let's look at the flow of this. We create the number of donuts variable, we grab it, create the bill variable. Now we evaluate the condition. Is it less than 12? If it is, it will run this line and then skip everything else until output time. If it's not, it will skip this line and go into whatever's in the else and only calculate that. So let's run this function. Number of donuts is equal to 12. Is it less than 12? No. F8, it skips that line. Else, there's no other condition. So as long as it doesn't meet the first condition, it will always go into whatever's in an else. An else is sort of a catch-all. So now it says yes, we're going to go to this line, it gets processed, and if now bill is set to 480, there's only one of these two lines ever being processed at once. Let's go back and let's change it now back to 1. Okay, let's stop it and start it over. F8. We grab the number of donuts, it's set to 1. Now here we get to this condition. Is it less than 12? Yes, it is. So it goes inside and calculates this line, then skips the else and moves to the end. This is a more efficient function because it will never assign bill a value twice. So again, an if statement is a control structure that helps us choose which lines of code we want to execute. And we always have a true-false condition that gets evaluated. It can't have more than 2 values, otherwise it won't work. Alright, so check, make sure you got this working. I'll hit stop, pause the video for a moment, make sure it works correctly, It's got to look exactly like my code. And then let's move on. Okay, now let's expand this. Let's add more conditions to the flowchart. Even though we've met this flowchart now, it works just fine. I want to make this if statement a bit more complicated to give you practice. Let's say that if it's not less than 12, or if it's greater than 12, if it's greater than 2 dozen, we're going to give it to them even cheaper. If they buy 2 dozen or more, we're going to discount it to 38 cents. So there's a few ways we can modify this. First of all, we can say, okay, if it's not less than 12, meaning it's greater than 12, let's also check if it's greater than 24. So there's two ways. We can start by putting what we call a nested if in here, which we've already learned about. If number of donuts is greater than or equal to 24, then bill will equal number of donuts times 38 cents. If it's not greater than 24, then that means it's still 12 or more, but it's less than 24, therefore it'll be 40 cents. Notice I have to have another end if that ends this nested if right here, whereas this end if is ending this first if. So let's test it out. Let's put it, let's say that we want 100 donuts, which is greater than 24. That means we should be paying $38, right? So let's come back here, let's process F8, grabs number of donuts, set to 100, not less than 34, clearly, else, which means we're going to go inside of this else statement. So it moves in here. Here's another condition to evaluate. Is it greater than 24? Yes, it is. It goes in here and sets bill equal to number of donuts times 38 cents. Skips this else, and then goes to the end of the outer if as well. Total bill is 38. Print out the value. There we go. Okay, let's set it to 20. That's in between 12 and 24. Stop it. Hit F8. It's not less than 12, so it skips that one. Goes into the else here. It's not greater than or equal to 24, so it skips that one. Goes into this else and says yes. This is when we calculate bill equals number of donuts times 40 cents. Therefore, bill is $8. That's correct. Notice from here I can just hit play and it'll finish out the function. So now back here we go. 20 donuts, $8. Okay, that's one way to do that. There's another way to handle this, using what's called an if-else. So I'm going to say, whoops, if it's not less than 12, then else if is it greater than 24? Delete this one and move this back. Is it greater than 24? If so, 38 cents. Otherwise, if it doesn't meet either of these first two conditions, then it's 40 cents. So what's the difference? Well, there's only one if block. There's no nested if. You can have as many of these else if lines as you want. You can say else if it's, let's say that if it's more than, if they order 100 donuts, we're going to give it to them for 30 cents a donut. So what I'm going to change this to then is, let me show you, it's a bit more complicated. Else if NOD is greater than or equal to 100, then bill equals NOD times 0. What did I say? Oh, I don't care. We'll make it 30. 30 cents each. Okay, but this if block has a problem. So when you create an if block, only one of them should ever be evaluated as true. Otherwise, you've got a problem. So let's say I order 50. Or no, sorry. Let's say I order 100 exactly. Okay, it's not less than 12. It'll skip that. It is greater than 24, so it's going to process this line. However, it's also greater than or equal to 100, which is the one we really wanted to process. Let me show you what I mean. Let's make this 100. Now come back here, F8. Okay, is it less than 12? No, so it skips it. Is it greater than or equal to 24? Yes, it is. So it goes in there. We don't want it to go in there. And since it went into that one, it automatically skips all others because it believes that only one condition should ever be evaluated as true in a single if block. So we need to modify this. This is where we can use the and or keyword. So right here, I can remember in Access we did the same thing. We can have multiple conditions in the same query. We can do the same thing in programming. Right here, I'm going to say if number of donuts is greater than or equal to 24, and it also has to meet the condition of being number of donuts less than 100. So now it'll only go into this condition if it meets, into this else, if it meets both this condition and this condition at once. Okay, so let's stop that, play it again. Less than 12, no it's not. Less than 24, sorry, greater than or equal to 24, and, oh, I wrote it wrong. Sorry, guys. This should say less than 100. Let's try that again. Okay, less than 12. It shouldn't meet this condition. Yeah, it meets the first one, but it doesn't meet the second one. And if I use the keyword and, it has to meet both of them, so it's going to skip it. Now, if I called that or, that would have broken it, because with an or in between two conditions, only one of them has to be met in order to move here. And in that case, it still would have gone in, which would have been incorrect. So now it goes into this one, yep, 30 cents a piece, and if, take a look, there it is, $30 as it should be. Okay, let's bring it all together with a nested if or else if statement. We're going to move on and have another example after this. Thanks.